Welcome students. So that was yet another question based on Rolle's theorem. Okay, it's a tricky question, so that's why I decided to share it with you and share this solution here, bachcho. So f of a is equal to f of b is equal to 0. We have to prove this statement for some c in the interval a to b, where fx and gx have to be differentiable function, no doubt about it. So the point is, from where will we get this expression? That's the point here. And from where the hell this came? G dash, like g dash of c. There's no g mentioned here, no condition of gs function, except that we are given that gx is a differentiable function. So given fa is equal to fb, and look at this and look at this. Okay, so for some c belonging to at least one c belonging to the interval a to b, fa is equal to f of b. So that leads us to Rolle's theorem, bachcho. But how will we get this expression? And we know that this statement we get if we are applying Rolle's theorem on any function f of x, then this type of statement we get for f dash x equal to 0 for some c belongs to, so f dash c equal to 0. We have to look for this function f of x, for which f of a can be equal to f of b, capital F I am talking about, because the small f is given here, bachcho. Okay, so now let's move ahead. See, here lies the trick, and we have to spend, at times we also spend several many minutes, maybe hours, to think about that function. Hit and trial type of thing also work here. So I will say, let us consider a function h of x, which is e raised to the power g of x into f of x. Now apply. Now see, h of a is this into f of a, 0. H of b, since you have f of b in multiplication, is 0. So h of a is equal to h of b. So h of a is equal to h of b. That's the first statement. So, and this function is definitely a differentiable function, because fx and gx both are differentiable functions. So that's a simple direct combination of fx and gx, but it's a differentiable function. Okay, so now apply Rolle's theorem on it. So applying Rolle's theorem, what do we get? So applying the theorem here, I'm not writing, I'm just writing theorem. Applying theorem here, what do we get? So h dash. So there will be some c such that h dash c is equal to 0 for some c in the interval a to b. Okay, now what we get when we differentiate it? You apply chain rule, product rule, both of them. So I will keep e raised power gx out of it and differentiate fx, which is f dash x, plus then keep fx out of derivative, differentiate e raised power gx, which give us the same function, and then using chain rule, the derivative of g dash x equal to 0 at x is equal to c, and c belongs to this interval. Okay, so what do we get? So we get, see, you can take e raised power g of c common, you have then f dash c plus g dash c into f of c equal to 0, since this can't be 0. Exponential function is always positive, greater than 0, so this imply, and that's it. See, solution is very crisp, very simple. I mean, solution, it's a very like it involves very few steps, but thinking this function is the key. So that's why I shared this question with you people, bachcho. So I mean, if you have an idea that we can think like this, we have to assume such type of function, then you can assume anything. You can think any type of function. It may take some time, but then you can think on it. Okay, so that's the idea here.